Okay, good morning. So we solved these problems in this homework. One of them you can use GeoGebra to calculate, but the rest of them I have mentioned don't use the digital help, okay? So the first question is the coefficient of x to the power of 29 in this expansion is equal to what? We are supposed to use GeoGebra to compute the final number, okay? So this shouldn't be hard. Yes, the binomial that we have is x squared minus 3 over x to the power of what? 25. And then we want to know the coefficient of x to the power of 29. Yes, the coefficient. Okay, so how should we do that? We use the formula. So the formula of binomial expansion is a plus b. A and b could be any real numbers. N should be a natural number. This is sigma, that which you will get this in the formula sheet. K goes from 0 to n. N is the same n. N, the same n, choose k, the counter. And then the first term to the power of n minus k. N, the same n, k, the counter. And b to the power of the counter. So that is the formula that you will receive. And then you want to use this to solve the problem. Comparing this one with this one, you can immediately realize that a is x squared here, b is what? Minus 3 over x, and then n is 25. Yes, this is what we know. And then I put them in the formula, so it becomes x squared minus 3 over x to the power of 25 is equal to sigma. K goes from 0 to 25. And then I have 25, choose k. A, which is x squared to the power of 25 minus k. And then multiplied by b, which is this one, to the power of k. Yes? And then I simplify it, as you have a little bit of experience. Last time we solved some problems of this type. So this becomes 25, choose k. Then I want to write it in a form that you can see one single power of x, and then equate the exponent of that power with 29 and find your k. And when the k is found, you can answer the coefficient. So that's this general strategy. So here, this becomes x to power what? 50 minus 2k. Minus 3 to power k is just a number. So let me write it here, minus 3 to power k. And this will be 1 over x to power k. I would recommend you to bring 1 over x, to bring x up and write it as x to power minus k. Yes? And then try to write it in a little bit more compact form. Minus 3 to the power of k is a number, so I put it next to this binomial coefficient. But no, we now know what happens here, yes? So it becomes x to the power. This exponent will be added to that exponent. It becomes minus 3k. So that is the expansion. But you need to know the coefficient of x29, okay? So this means that you have to ask yourself for which value of k the exponent 50 minus 3k is equal to 20. And then you can solve that, yes? So minus 3k, I move this to the other side, it becomes minus 21. So k becomes 7, yes? When k becomes 7, be careful. Everything here is considered the coefficient, not just the binomial one. Any number that appears next to x to the 29 as a whole is considered the coefficient. So I have to put k back here and answer the question mark. But for this calculation, that is the reason I have given you access to GeoGebra. So what should I write? The question mark is equal to 25, choose 7, and multiplied by minus 7 to power, to power 7. Yes? So, and then I hope that you know how to do it in GeoGebra. So, for example, let me open this up. I mean, algebra view is good enough for this purpose. So what should I do? This is the way that we type N capital C R This is the binomial expansion. I press enter once, press enter another time, and for n I put 25, comma, r is 7, yes? And then in front of it a space for multiplication, and I have minus 3, multiplication, and I have minus, is it Swedish keyboard? Yes, that's why I have to change the keyboard. Okay, so it's now, so I don't know why, it doesn't matter. So it is minus 3 to the power of 7. Yes? So that is the number that you are supposed to type in that empty space. Is that okay? Okay. So this is done. We don't need any GeoGebra anymore. So let me just close it. Yes. Okay. Now we go to the next problem. The next problem, as you see, is this one. So let me make it a little bit bigger. Okay. So this number is equal to which one? Okay, of course, one way is to sit down and calculate all these numbers, add them up and calculate these things to see which one matches. Okay, so of course, this is not the idea, probably you know. So what should we do? So what are the numbers? I have 10 choose 5 plus 10 choose 4 plus I have 11 choose 4 plus I have 12 choose 4. Yes? Do you have any idea what to do? Yes?
I don't know the name of it, but
Pascal identity, yes? So what was it? It was if you have n choose r, you can decompose it into two binomial coefficients. One of them is n minus 1. Do you remember the story I told you behind that? So if you forget, you can just immediately tell that story to yourself. So I want to choose r people out of n people. Okay, so concentrate on the last person. Either you choose the last person or you don't. Okay, the number of ways that you can choose the last person, it means that from the leftovers, you have to choose r minus 1, so that with that one person, totally it becomes r people. Or what do? You don't completely ignore the person. So from n minus 1 left, you choose r people. Okay, so that is the story behind that, so you can always remember the formula if you forget. So, but for our purpose, the other way is important. Yes, I want to combine these to make them simpler. But so let us understand that if I have two binomial expansions like this is, by the way, called binomial coefficients. These numbers are called binomial coefficients for the same reason that it appears in the binomial expansion. So if the top numbers are the same and the numbers in the bottom, they differ by 1 unit, and you are supposed to add them, you can combine them into one binomial coefficient whose top number is 1 more, and between these two you choose the bigger one. Okay, so now is it applicable here? For example, you see that the top numbers are the same, these two numbers differ by 1, so according to this one, these two can be combined to what? I choose the number which is 1 unit more, which is 11, and between these two I choose the bigger one. Yes? Okay. But the rest of it I have to copy and paste for the time being. Yes? Because that is not any Pascal identity anymore, because these two numbers also differ by 1 unit. These numbers are the same. This is the other way around. Okay, but what should I do? I hope that you see what is happening now. Yes? So what I did, for these two, using this identity, I wrote this and I copied and pasted the rest. But now you can see what happens. Now these two form another Pascal identity, yes? Because these numbers are the same, they differ by 1 unit, so I can combine them into one binomial coefficient whose top number is 1 more, and the bottom number is the bigger one. Yes, and then the same story. Now this one with the last one makes another Pascal identity. Yes, so what should I write? I write 13. Between these two, I choose 5. Is it there? Yes. So if you go here, you see that this answer is the correct answer. Yes? Any questions? Okay, so now let us go to the next one. Make this one. This was a little bit more interesting. The number of integer terms in this expansion is equal to what? Okay, so we want to see, because you know that, for example, if I want to give you a simple example, if I have square root of 2, let me make it plus 1 to the power, let me make it plus square root of 3, and then I just raise it to power 2. If I raise this to power 2, this third sign sometimes survives, sometimes is eliminated. So they are asking about the number of terms so that you don't have any surd signs. You want to have integer terms. So if I raise it to power 2, becomes the first one to power 2 plus 2 times the first one times the second one plus the second one to power 2. Now if I ask you how many integer terms you see, you answer 2. One of them is 2, the other one is 3. This is not the integer term because the surd sign survives. Okay, so that is the same question, harder version of it. Okay, so what is the question now? It is the fourth root of 9 plus the sixth root of 8, and the power is 500. Okay, so if I want to see that if I sit down and expand, and then how many integer terms I will have. Okay, so let us use the binomial formula. So it is on the board now. Where is this still? Yes, here. So if you compare this one with the standard formula, so A is this number, B is this number, and C is this number, N is this number. So let me just put them here. So it goes, K goes from 0 to 500. Then I have 500 choose K, and I have this number, the fourth root of 9 to power 500 minus K, and the sixth root of 8 to power K. Okay? So you don't need to be worried about this because this is a coefficient, this is a binomial coefficient, and you already know that this is always an integer. So you need to work here. And then based on the experience we got from the previous problems, you know that usually surd signs are not suitable for answering these questions, so let us get rid of the surd signs. Okay, so for example, what can I do? Here, I can write it as 9 to the power of 1 over 4, but that power of 1 over 4 will be multiplied here, so it becomes 9 to power 500 minus k over 4. Yes, and then this one becomes what? 8 to power 1 over 6, but 1 over 6 will be multiplied by k. It becomes k over 6. Yes, but I prefer to make it a little bit simpler. Instead of working with 9 and 8, let me write 3 to power 2, 2 to power 3. So the exponents will be these, the denominators will be a little bit small. Yes, so if I write this one, what happens? Again, this becomes 3 to the power of 2. That power of 2 will be multiplied here, so it becomes what? 500 minus k over 2. And then the other one becomes 2 to power 3, but that exponent of 3 will be multiplied here, so this becomes k over. Okay, so now the question is that you want to have integer terms. So integer terms means that this power, this exponent should not be a fraction, because if it remains a fraction, then that will be a third, it will be a non-integer number. So this should also not be a fraction. So this means that I have to see for how many of these k's from 0 to 500, both of them, so this should be even, because if this is even, I will get rid of this 2 and I will have an integer coefficient. I want simultaneously k be also even. Yes? So my goal is to see for how many k values k is even which allows me to get rid of the third sign here, and simultaneously 500 minus k over 2 is also even, which will allow me to get rid of the third sign here. Yes? Okay, so what should I do? Can you see how can I solve this problem? So the numbers that are involved are 0, 1, 2, 3, up to 500. 500 minus 2 minus k should be even, and k itself should also be even. So I think that you see that both of them are give me the same condition. Do you agree? Because on the one hand, I want to have k even. So if k is even, this one is automatically satisfied. So I don't say that I have two conditions. I have only one condition, because one condition will automatically give rise to the other condition as well. So either you take this one and work with it, or you take this one. Of course, this one is simpler. So the question is very simple. I had this list. I want to see in how many of them k is even. Okay, and that is not hard. How many?
But
Yes?
it's not 500 minus k over 2 that needs to be even, or...
Ah, yes. No. That's why. So here, no, this should be even. Yes, because the denominator of 500 minus k is 2. The denominator of k is 2. If this one is even, I get rid of the fraction form. I will get an integer, and 2 to the power of integer becomes, and this one this. So both of them should be even. So, and then because both of them means the same thing, so let us just work with one of them. Do you understand that? Yes, why we should work with one of them. So this the point is that in this list, how many even numbers you see? So the first one in the list is what? 0. The second one is 2. And the last one is 500. Do you know how to calculate? The last one minus the first one divided by 2. But remember, there is one extra 1 there. Okay, some people forget about this extra 1. For example, if I say, how many numbers, all numbers from 1 to 10, including 1 and 10. If you say 10 minus 1, of course it is wrong, yes? Because how many numbers are there? 1, 2, 3, up to 10. There are 10 numbers. But if you say the highest one minus the lowest one, it becomes 9. Okay, so remember, I proved this for you before, you remember? So if you have an arithmetic progression, this is an arithmetic progression, yes? Every time you are adding 2 units, okay? So this is the formula. A number n is a number 1 plus n minus 1 times the common difference. Here the common difference is, so if I want to know what is the number of terms involved, I take a n minus a 1, I divide by d, but you see it is not n, it is n minus 1. So if you want to find n, you have to move this 1 to the other side. So this 1 is actually coming from there. So 500 divided by 2 is 250, and this one 251. So there are 251 terms involved in this that are integers. Any questions? Okay, so that was not a bad question, so it was good. Let us go to the next one. Okay, what is this one now? Yeah, this is a little bit more interesting. You need to find the idea behind that. If the sum of the coefficients in the expansion of this is 243, then the term independent of x is equal to what? Okay, so let me, you can read the question. I will erase the board. Okay, let us clean everything. Okay, so is the question understandable? Okay, so we know something about this expansion, x to power 2 plus 2 over x cubed to the power of n. We know that if you expand this, the sum of the coefficients is equal to 243. And then we want to know what is the term independent of x in this expansion. Of course, it is clear the idea. The first piece of information is given to you to help you to find the unknown in your problem. What is the unknown in your problem? N. And then when you have n settled down, you remember we solved some problem like this before, how to find the independent term. So that's a combination of two problems. But you have to understand how you can use the first piece of information. How can you find, how can you use the piece of information provided for you? Yes?
You can say the sum from k equals 0 to n of n choose k is 243.
No, that's a little bit more complicated than that, because the sum of the coefficients, the binomial coefficients are not just the coefficients, because there is a 2 here as well. So let me write the formula at least. So if I want to raise it to power n, let me write the binomial expansion formula. So in case k goes from 0 to n choose k, and then you have the first one to power n minus k, and the second one to power k. But the second one to power k is what? 2 to power k divided by x3 to power k. Let me write it, by the way, this will be useful. So let me simplify it. So this 2 to power k will also be considered some kind of coefficient here. Yes? And then here, this is x to the power of 2n minus 2k. I multiply that and I bring this up. When I bring it up, it becomes x to the power minus 3k. The exponents will be combined here. Yes? And instead of writing minus 2k minus 3k, I would write just simply minus 5k. So that's my structure. And then the question is telling you, so you see, if I put 0, so let me just, if you want to understand what's going on. If I put 0, it means n choose 0, 2 to power 0. And then I have some x to power what? 2n minus 0. This is the first term. The second term is what? N choose 1, 2 to power 1, x to power 2n minus what? 5. Do you agree? Because if I replace k with 1, the next one, this is. And then the next one is, for example, n choose 2, 2 to power 2, x to power 2n minus 10. And this list continues until I reach to the end. So this means that this will be n choose n, 2 to the power of n, x to the power of what? No, if you put n. So it becomes a negative power.
Minus 3.
Minus 3. Yes? Is that, yes?
Is it possible to put x as well?
Yes, that's what I'm saying. I'm coming to that. So that's what I want you to understand. You don't really need to, but if to have a good grasp of what is going on, this is what is happening. And this problem is asking you about not the sum of the binomial terms, because there is a formula for the sum of the binomial terms. I don't know, did you do it yourself or not? We will come back to it, okay, if you haven't done. Because if they ask you about the sum of these only, there is a formula for it always. And the formula is just 2 to the power of n. If you don't know how, I will come back to it, okay? But they are not asking about the sum of these. They are asking about the sum of this one, and that one, and that one, up to there. Okay? And that is exactly what you mentioned. So if you want to find the sum of the coefficients, there is a nice trick. Yes? Why? You said to replace x with 1. And you see why it works. If I replace x with 1, this is gone, because 1 to power 2n is just 1. The next one will gone. The next one, what is left for you is just the sum that you are interested to find the result. Is that clear? So this is a trick. Remember, if you want to find the sum of the coefficients of a polynomial or in an expansion, the trick is to replace x with 1. This will give you the sum of the coefficients. Okay, but because this is a formula, it means that if you replace x with 1 there, or if you replace x with 1 there, the result should be the same. So this means that the sum of the coefficients is equal to what? Is equal to that expression if I replace x with 1. Is that, I just wanted to justify this. Is that understandable? Yes. But this is very easy to calculate. This is 1, this is just 2, so it becomes 3 to power n. So on the one hand, I know that the sum of the coefficients, according to my calculation, should be this number, but according to what is given in the problem, should be this number. So they have to be the same. So this means that 3 to power n, which is based on my calculation, should match with the information given in the problem. And then it is not hard to see what n is. This is what? 81 times 3. 81 is 3 to power 4, so this is 3 to power 5. So this means that n is 5. So this is the piece of information that was missing from the problem. But now the second part of the question, now that you know n is 5, you put them back here in this formula. K goes from 0 to n is 5. 5 choose k. And then this becomes 2 to the power of k. And x to the power of what? 10 minus 5k. If n is 5. But now you want to make it independent of x. What does it mean? It means that you want to expand, but you don't want to see any track of x. So it means that there is only one thing that you can do to get rid of x, to put the exponent equal to 0. So you ask yourself when this becomes 0. The answer is simply k is 2. So then the question mark is what? Put 2 back here. So this becomes 5, choose 2. 2 to the power of, 2 to the power of 2. But this I have it in my memory, but this is also simple, so that's why you don't need calculator to calculate this, okay? This is 10, this is 4, so this becomes 40. Calculating this is so simple, yes, isn't it? Do you want me to calculate or you know how to calculate? Yes, you just put in the formula. So that was also a good problem, I would say. Okay, any questions so far? So this is the trick, remember, if you want to find the sum of the coefficients, replace x with 1. Yes? Very good. Okay, so let us go to the next problem. Here, we are supposed to calculate this number. Okay? You can think a little bit about yourself. Because finding these combinatorial numbers are not that easy. Of course, we can always do it case by case. For example, we can use GeoGebra to calculate this without typing using the sum, yes, but let us do it later. But here, if I want to solve this, let me write it on the board. So, we want to know this number. 10 choose 3, 10 choose 0, and then minus 3, 10 choose 1, the next one plus 3 to power 2, 10 choose 2, and then minus, so alternatingly you are changing the sign, the pattern is clear now, and then 3 to, and every time you are multiplying, by minus 3, and then you are keeping this 10 constant, but you are increasing the bottom number, 0, 1, 2, up to what? 10. And then we are supposed to calculate this number. Of course, this is not in principle a hard problem. In the worst case scenario, you sit down and calculate turn by turn, but that is not, of course, the idea of this problem. What do you think is the idea?
Make it like a sum with minus 1 to the power of n as a
No, think, this is the, of course, you already have one good guide. This is the homework for binomial expansion. So this means somehow this should be related to binomial expansion. This is very good, by the way. These are good tricks that the students should learn, yes? If the homework is about binomial expansion, so it means that binomial expansion is somehow relevant. Okay? So if you don't mind, let me write the formula here for you. Sigma, let me write it the other way around. Sigma, k goes from 0 to n choose k, a to the power of n minus k, b to power k is equal to a plus b to the power of n. This is the formula written in the other way around. The reason I did that, because I have a sum, so I wrote the sum on the left. So now is it clear what I'm going to do? I want to do some engineering so that engineering means choose A and B wisely so that when you replace, choose not only A and B but also N wisely so that this can be matched with this. If you can, that is the only thing. There is nothing that I can help you. That is, by the way, not hard. You need to guess what A should be, what B should be, what N should be, so that when you put A, B, and N here, this sigma generates that question mark sign. If you can but sometimes, of course, the guessing here is not hard, but sometimes they are hard. They are not that easy, okay? But if this is easy, I just want to give you a feeling of what kind of things you might expect. Okay, so how can I engineer that? Do you guess what should I choose for A, what should I choose for B, and what should I choose for N? I think for N is the simplest scenario. Yes, what is N? If it is going to work, N should be 10. Yes, because the top number is always 10. What do you choose for A?
Choose 1.
Let us test. You say 1. I will go with you. And if it works, it works. Otherwise, we change. Okay? So A is 1. What do you guess for B?
-3.
You say -3. Okay, so let us check if it is working or not. So if your guess is correct, the sigma will be K goes from 0 to 10. N, according to what you said, is 10. Choose K. And then you said A is 1. So N to power N minus K. And then you said B -3 to power K. Okay? Do you think it works or not?
Maybe. No,
It will work, I think. Yes, do you agree? Because first of all, this is not a big problem. 1 to any power is just 1, so it is gone because it is 1. And this becomes, let me write it a little bit organized. So let me write -3 to power K on the left. Let me write this binomial coefficient on the right. And then K goes from 0 to 10. Let us open it up to make sure that everything is right. I replace K with 0. So this becomes, do you agree? Positive 10, choose 0. Because -3 to power 0 is just 1. The next one, I choose K to be 1. When K is 1, this becomes -3 to power 1, which becomes -3. And the next one becomes 10, choose 1. Yeah, apparently it works. If I replace K with 2, it becomes -3 to power 2. But because 2 is even, I don't need the minus sign. So it becomes +3 to power 2. And then 10, choose 2. It seems it is working, yes? And then the next one, of course, becomes negative because I will choose K. And it will continue until the very last. The very last is positive or negative. -3 to power 10 is definitely positive because 10 is even. And then I will have 10 choose. Yes, that's good. So this means that what you chose is correct. Okay, so this means that if you choose these numbers, the left-hand side matches with my question mark. But on the other hand, the left-hand side, according to the binomial theorem, is equal to this expression. So if you replace A, B, and N with these numbers on the left, you are allowed to replace them on the right as well. They should match. So this becomes what? 1 -3 to power 10. And then 1 -3 is what? -2 to power 10. I have it in my memory. I hope that this is not a big problem to calculate. So it is 1024. So that is the answer to the sum. And of course, if you want to check it using GeoGebra, how do you do that? How do you do that? Do you have any idea? So we use the instruction sum. Yes. Sum expression variable start value end value. So what is my expression? My expression is exactly what I wrote there. So I would write n, choose r, and then the numbers are what? 10 and k. Do you agree?
you didn't do the bracket.
Okay. So I have to put a pair of brackets there. And then this is the problem with GeoGebra, so I have to clean everything now. So, and then 10 and k. Yes, is that right?
Yep.
This is, but you multiplied by? Multiplied by -3 to power k. -3 and then to power k. So, what is the name of my variable? K. What is the lowest value?
0.
0. What is the highest value? 10. Yes, and that's your answer. So I use the sigma. Instead of sigma in GeoGebra, you have the word sum. Okay, but that's more or less the same thing. So yes, we are on the right track. Okay, now let us take this opportunity to actually ask you, do you remember, this is a very important formula, 0n plus 1n plus 2n up to nn. This is the sum of the binomial coefficients. This is a very important and famous formula. This becomes always 2 to power n. We can solve this problem using the storytelling proof, one way, which is very good, and one way is the binomial expansion. Okay, so if I want to use this, because this is very similar to this trick now. Okay, so what is the formula of binomial expression? A plus b to power n equals to sigma, k goes from 0 to n choose k, a to power n minus k, b to power k. Yes? Now, do you see what are these numbers? These numbers are the sum of these coefficients as if a and b are not there. So I have to somehow get rid of a and b. But of course, I cannot throw them out. I choose wisely. What should a be? What should b be? So what do you think I should choose? 1, both 1. So if I put a 1, b 1, then instead of a and b, I put 1. 1 to some power is just 1. This one is also 1. So what is left for me is this one. Do you agree?
Yeah.
And if I say open it up, do you agree that you will get the same sum?
Yeah.
If I open this. So this one is the left-hand side of that, but what is this one? This is 1 plus 1 to power and 2 to power n. So that is why this is a very famous formula in combinatorics. That if you have these coefficients, add them up, it becomes 2 to the power of n. But what is the story behind that? If you want to prove it using a story,
Story.
yeah. Talk about something in the set theory. Subsets. Very good. So if I give you a set, just A equals to 1, 2, 3, up to n. Yes? If I ask you how many subsets are there, one side of the story, you can immediately answer. How many subsets are there? 2 to the power of n. This is one side of the story. But let me answer the same question in the story in a different way. If I want to find all subsets, some subsets of with 0 element, of course that is the unique one. Which one is that? The empty set. Some subsets has one element in them. So for example, this set is a subset with one element. This set is another subset with one element. And then some subsets have 2 elements, some subsets have 3 elements, and some subsets, in this case again 1, has n elements. So it is clear that if I know how many of each one of them are there, add them up, you should give me the same. So that is another way. Okay, if I ask you how many 0 element subsets you have, you say that, okay, I have n elements, I want to choose 0 of them. Of course, this is 1. And then if I ask you how many 1 element subsets are there, you say that for having a 1 element subset, I need to choose 1 out of n. It is a combination problem, not a permutation. Why? Because in the set, order doesn't matter. Okay? So then the next one becomes, okay, I have n elements, I choose 1 of them. This gives me the number of choices that I have if I want to choose 1, if I want to write a subset with 1 element. The number of choices that I have if I want to choose 2, and the number of choices that I have if I want to. I hope that you agree that if you add them up, you are counting again the same number, the number of all subsets. So the number of all subsets on the one hand should be this, which we learned it from the product principle, and should be this one if we counted, if we change our counting strategy. But because we are counting the same thing, these two numbers should match. That is the story proof telling for this. Any questions? Okay, so now let us see if we can go to the next problem. The last problem is a little bit more interesting, I would say. So let me make it a little bit bigger. Okay. this is given, a binomial expansion is given using this formula, and then you are supposed to answer what happens here if I calculate this product, which one of the options will be available. So is that understandable? What does it mean? Yes, it means that if you raise it to power n, of course, this is a binomial expansion that is not under your control. It will give you something. But that something turns out, if that something is being this, then these coefficients, a sub k, putting them here and calculate will give you what? That is the idea behind the problem. Okay, so you can think a little bit about it until I can erase the board. Could you get some idea what to do? So the problem is this. They are telling you that if you have 1 plus x to power n, it is in the form of this. K goes from 0 to n. A, which we don't know, a sub k times x to power k. First of all, I hope that this is understandable, yes? Because if you use binomial theorem to expand that, you will get a polynomial of degree n, of course. Is that understandable? Okay, if not, let me explain. So what is wanted here is this one. Let me write it here. What is that? 2a1, and then you want to continue this product until you reach to this. So you want to continue this pattern, and then you want to know what the answer is. Okay, I hope that you at least know where to start. What do you think is a good starting point? Yes?
Rewrite the left side.
Yes, there's nothing we can do. So let me write the left-hand side using binomial expansion. But here, that a in the binomial expansion formula is 1, b is what? Yes, b is x, and n is just n. Yes? So let us expand that. So I don't want to rewrite the formula. Hopefully you have it at least a little bit in your memory. And then, because the right-hand side in a counter is k, let me also choose k, because I want to compare them. It doesn't matter, of course. You can open them up and then compare them term by term. Yes? So k goes from 0 to n. N choose k, but a, which is 1, to power n minus k, and then b, which is x, to the power of? Is that right? Okay, so 1 to any power is itself. So what is happening now? It becomes just simply x to power k. A very simple problem, it's not hard. Yes? And then if you compare this one, you can read what is a sub k. Because if this is a polynomial of degree n, that's also a polynomial of degree n, and they are supposed to be identical, it means that the coefficients should be correspondingly the same. So by comparing this with that, I will understand that a sub k is what? N choose k for which values of k? For all values of k relevant here. k0, 1, 2, up to. Okay? Okay, and now, of course, one way to deal with this is to put this expression for k1 and 0 here, for k2 and 1 here, and etc. That is possible, but let us, because all these structures are the same, so let me concentrate on one of them and see what happens for one of them. Might be I get some kind of pattern, then I can immediately understand what's happening to the rest. Okay, so what do I mean by that? For example, if I want to pick one of them, you see that the structure is 1 plus a fraction, and this is a and a, but they differ by 1 unit. For example, if I choose this one to be a sub k, what should I write for this one? You see, if this is 1, this is 0. If this is 2, this is 1. If this is n, this is n minus 1. So I choose this one. And I ask myself, can I say something about one of them only, not all of them simultaneously? Okay, let us do that. So this becomes 1 plus, what can I write for a sub k? I got it there.
And choose k.
But what can I write for a sub k minus 1? And choose k minus 1. Yes? I don't know which way is better here. You might, if you take the common denominator, it becomes a Pascal identity, I think. But is it useful? Not that much.
Okay, let me simplify it. Okay, why should I make trouble for myself? So the formula for this is not hard, is n factorial divided by what? K factorial n minus k factorial. Many things will be simplified. This one is the same thing, but k minus 1 is playing the role of k. So this becomes n factorial divided by what? K minus 1 factorial. The difference between them, n minus k minus 1, which becomes n minus k plus 1. So it becomes n minus k plus 1 factorial, yes? And then this one and that one are gone. Okay, let me not be in a hurry. So I will write 1 plus, this will go to the numerator, this will go to the denominator. So this becomes k minus 1 factorial multiplied by n minus k plus 1 factorial and divided by k factorial n minus k factorial. And of course, I hope that you see that there are a lot of things that can be simplified now, yes? For example, this k factorial can be visualized as k times k minus 1 factorial. And this one can be visualized as n minus k plus 1 times the previous one, n minus k factorial. And then what happens? This n minus k factorial cancels that one, and this k minus 1 factorial cancels that one. So what is left for me is 1 plus, from the numerator, n minus k plus 1 is left, and from the denominator, k is left. And now I take the common denominator. So what happens? K, this k goes up there, n minus k plus 1. But this k and that k also cancel. This is what I get for any typical k in the range. Okay, but I hope that now you see what is happening, yes? So the question mark is equal to. So what I proved that a sub k for any k in this range is equal to n plus 1 over k. It's a very nice pattern. You see, any a sub k is a fraction. The denominator of the fraction is the index here, and the numerator is independent of k. It is n plus 1. So it means what? It means that if I want to write this, oh sorry, what was that? That was not ak. That was my mistake. That was not ak. What was it? It was 1 plus. It was 1 plus ak over ak. I was able to show that if you pick any k in this range and concentrate on this structure, this becomes equal to this. This k that you see up there goes to the denominator, and the numerator is n plus 1. Okay, so now can you tell me, for example, according to the formula that we derived, what can I write for this one? You just need to read k. What is k in this first one? K is 1. Yes? So what should I write for the first one? N plus 1 divided by 1. Okay, what about the next one? N plus 1 again divided by 2. Yes? And then this will continue until the last one. The last one, which one is playing the role of k? N. So it goes n here, but what is the numerator? N plus 1. So you just need to multiply them. If you multiply the numerator, that is the same number being multiplied by itself. How many times? From 1 to n times. So it becomes n plus 1 to power n. And in the denominator, you see 1 times 2 up to n, which has a name. What is it? N factorial. So that is the answer. Yes? Is it there or not? Yes, it is here. It was a good question. It was not hard. Yes, but I would say that it was reasonable. Yes? Any questions about the problems?
You could also, you said you shouldn't write 1 as a sub k minus 1 divided by a sub k minus 1.
1?
Yeah, like when you have 1 plus ak divided by ak minus 1, you can rewrite 1 as ak minus 1 divided by ak.
Is it useful? I'm not saying no. Might be it is useful.
Why
For
wasn't it
example,
useful? That was my question.
no, at the end I use that
Ah.
because you see at the end I brought this k into the fraction.
thought that's just faster to do it at the end.
I thought that it is faster, but that is just subjective. You can do the other way. Because I'm sure that if it goes there, so if it goes there, it becomes a Pascal identity. But let us see if it will help me. So here it becomes nk minus 1. But if it goes here, imagine it is here and being added there. So according to Pascal identity, it becomes n plus 1.
Yeah, and then
K.
plus one.
This.
Sorry, yeah.
But then, of course, you have to still simplify it, I think. So it doesn't matter. That's up to you. Okay. Any questions? So let me stop this recording. Thank you.